What's up everybody, I'm Wallace from A3Academy, and today we're going to be talking about linear momentum. Specifically, we're going to be talking about linear momentum in one dimension, which basically means that the objects are traveling along a straight line. So let's get started. The basics of linear momentum. Usually we represent linear momentum with the lowercase p, and you can find the momentum of an object by multiplying the mass by the velocity. Another thing to know is that the units that we use for momentum are kilogram times meters per second. So that's useful when you want to use the correct units. So to recap how to calculate linear momentum, suppose we had an object with a mass of 20 kilograms and that object is moving at a speed of 5 meters per second. The momentum is simply 20 times 5, which is 100 kilogram meters per second. So now one of the things we know about the momentum is that when two objects collide, the momentum before the collision is equal to the momentum after the collision. And this principle is known as the conservation of linear momentum. And so basically an equation is the total initial momentum is equal to the total final momentum. And to illustrate this concept, we're going to have a couple example problems. So the first example problem is we have two cars. One is a green car, one's a red car. The green car is 1,500 kilograms and the red car is 2,000 kilograms. Now, suppose that these cars are on a collision course. The green car is moving toward the red car at a speed of 20 meters per second, and the red car is moving at 18 meters per second. And suppose that these two cars collide with each other and bounce off of each other. And after they bounce off, we notice that the 2,000 kilogram red car is moving at a speed of 12 meters per second. Now, the question is, how fast is the 1,500 kilogram green car moving after the collision? This is really easy to solve as long as we consider the conservation of linear momentum. Remember that equation that we had earlier, the total initial momentum is equal to the total final momentum. So let's first try to calculate the total initial momentum. If we take a look at our initial conditions, first thing we need to do is establish a positive direction. Usually this is established to be to the right. However, you can set your positive direction to the left or to the right, and the answer to the problem will still be the same as long as you're consistent. So if we consider this direction to be the positive direction, we know that the green car is moving to the right, which is in the positive direction, so we can say that it's moving at a positive velocity. However, the red car is moving in the opposite of the positive direction, to the left. That means that we can say that it's moving at a negative velocity, or negative 18 meters per second. Now that we know the velocities and the masses of both the objects, it'll be really easy to figure out the momentum of both the objects. All we have to do is multiply the mass by the velocity for both of them. So, we can determine both the mass and the velocity for the green car and the red car. To find the total momentum of the entire system, all we have to do is add the momentum of the green car and the red car, and we will end up with negative 6,000 kilogram meters per second. That's the momentum of the whole system. Now remember that equation we had earlier, the total initial momentum is the total final momentum. Our total initial momentum is negative 6,000, which means our total final momentum also has to be negative 6,000. Now let's take a look at what happened after the collision. We know that the red car is moving at a speed of 12 meters per second. Now we know that the green car is moving to the left at a speed of, say, x meters per second. Now if we establish a positive direction again, we'll be able to find that the green car is moving in the negative direction, which means that its velocity is negative x, whereas the velocity of the red car is plus 12. All we have to do now is multiply out the masses and the velocities of both the cars, and we'll be able to figure out the momentum. To find the total momentum of the system, we add them together, and this should be equal to negative 6,000 because of the conservation of linear momentum. Solving for x, we will get that x equals 20, or in other words, the green car is moving in this direction at a speed of 20 meters per second. That wasn't all that hard, so let's have another example problem. Suppose that we had a gun with a mass of 0.8 kilograms that shot a bullet that had a mass of 20 grams and was moving at a speed of 300 meters per second. When a gun shoots a bullet, the gun will recoil. So the question asks, what is the speed at which the gun recoils? Once again, we can use conservation of momentum to figure this out. Let's wind the time back to when the bullet was still in the gun. Notice how both the gun and the bullet are moving at 0 meters per second. They're both at rest, which means that the total momentum of the system to start with is 0. Remember that momentum is conserved before and after the bullet is fired, which means that the total final momentum is also going to be equal to 0. Now let's take a look at what happens after the bullet gets fired. First, let's establish what direction the positive direction is in. We know that the bullet is traveling in the positive direction while the gun is traveling in the negative direction. So we'll say that the gun is traveling at negative x meters per second. To find the momentum of both the gun and the bullet, all we have to do is multiply out the masses times the velocities. Notice that for the mass of the bullet, I used 0.02 kilograms instead of 20 grams. It's always important to use proper units when you're calculating the momentum of an object. So to find the total momentum of the system, we add the momentum of the gun and the momentum of the bullet. And we should be able to get negative x times 0.8 plus 300 times 0.02 is the total momentum of this system. This total final momentum has to be equal to our total initial momentum, which, as we figured out earlier, is equal to 0. Solving for x, we get that x is equal to 7.5. In other words, the gun is recoiling at 7.5 meters per second. Wow, that wasn't too hard either. Let's have one last example problem. Let's suppose we had two boxcars, one green and one red. The green one's 5,000 kilograms, the red one is 3,000 kilograms. Now suppose the green boxcar is moving toward the red boxcar, which is at rest, at a speed of 10 meters per second. Now furthermore, let's suppose that these two boxcars latch onto each other after they collide. The question is, how fast are these two boxcars moving after they collide and latch onto each other? Well, let's take a look at our initial conditions. First, we have to establish our positive direction. Now we know that the green car is moving at plus 10 meters per second, while the red car is not moving at all, which means that it has a velocity of 0 meters per second. Therefore, since we know the masses of the boxcars as well, we can multiply those out and find out what the momentum of both these objects are. Adding them together gives us our total momentum for the system, which is 50,000 kilogram meters per second. Remember that equation we had earlier, the total initial momentum is equal to 50,000, which means that our total final momentum also has to be equal to 50,000. Now let's take a look at what happens when the boxcars latch onto each other. When they latch onto each other, they behave like one object. They move back and forth with each other, which means that we can really consider it to be one object, with a combined mass of 8,000 kilograms. The unknown here is velocity, which we'll call x meters per second. Since we know the combined mass and the velocity of the two boxcars, we'll be able to figure out the momentum, which is just equal to 8,000 times x. As we said earlier, the final momentum has to be equal to 50,000. Solving for x, we get that x is equal to 6.25. In other words, the combined speed of these two boxcars after they collide is equal to 6.25 meters per second. And that's basically how linear momentum works and how it's conserved. If you enjoyed this video, make sure to check out our other videos on our YouTube channel, like us up on Facebook, follow us on Twitter, and as always, the more you know, the better you are.